Yeah, so I'll just give a brief intro of what we are going to cover today. So in last lecture, we saw a bit of Google Colab, and it might have been a little bit overwhelming for you. We thought so. We are going to cover Google Colab again initially, and we have taken a very interesting example, which is also kind of customizable. So the notebook which we are going to be showing today is very closely related to the final projects that you guys will be doing. So yeah, Sridhar will share his screen now, and he'll start with the session. So just make sure you understand all the aspects of what we are going to be teaching today. It's going to be a bit of revision of Google Colab and then how to use the interface, etc. as well.
Yeah. So thanks, Rajat. So for those of you who do not know exactly what Google Colab is, it's one platform where you can run Python code. But other than Google Colab, there are many other platforms which allow you to run codes in Python, right? So this is hosted on the cloud, right? You are not running anything on the computer. Everything is on the cloud. But you can also install Python on your computer and try to run it in your using your operating system. You operate the Python and then let the Python in your computer run the code. That's also possible. So there are different ways in which same code can be run. I had this confusion initially when I started, like this was many years ago. I did not understand what is Jupyter Notebook, what is Google Colab. Then you have Kaggle. On Kaggle itself, you can run the code. Basically, all you need is a Python compiler. Sometimes the compiler might be hosted somewhere on the cloud so that you can run, compile the Python code using that compiler. Sometimes you will have it on your computer itself, which means you don't need internet. In this case, Google Colab is running things on the cloud. So this is the notebook. I have also made a copy of it. What I can do is maybe I can share this with you. So you can also try running the code along with me. And even with the link, I guess viewer. So I think you will have to make your own local copy if I'm not wrong. So please go to this link. We can run this whole thing from scratch together. And let me know if for any reason it's not accessible or something. In Google Colab, you can add two types of things. So if I move my mouse pointer over here, you can see that, I'm just moving it down, right? Just focus on my mouse pointer. It's showing code or text. So I can add text by clicking plus text. And then here I can type something. This is a sample text. So this is how I added, we added these headings, right? So you can add text. So that text will help us explain the code if someone else is looking at our code. Or you can also add code. So here, all of this is not code. This is just pure text. So code is over here. It starts over here. This is code. Whatever you see in this kind of a code block with this run icon, it's code that you can run. So this notebook is currently complete. So we will not be writing the notebook from scratch, but we will be going through it fully from scratch. The only reason why we are showing this notebook to you is because when you are working on your own projects, right? We have proposed different topics. Most of you will be executing your code in Google Colab itself. So it's very helpful for you to understand how one AI ML project is implemented using Google Colab, because then it can be broadly applied to many other AI ML projects. I have also kept ChatGPT open here because I just want to show you how you can use ChatGPT also to, let's say, learn the syntax. If you don't know the syntax of a particular line of code, I'll also show you how to you can create some code that you don't know using ChatGPT. But ultimately, the work you will have to do, but ChatGPT can do some heavy lifting for you. So just have it, if you want, you can also have ChatGPT open on the side. So this project is about predicting brain tumor. And brain tumor classification is a very famous project. So if you just Google, brain tumor classification, there are a bunch of results that will come. And I'm sure Kaggle notebook will be one of them, if not research papers. So see this brain tumor classification using MRI. This is a famous, very famous project. I'm sure some of you might have already seen this or heard of this. And what we are going to do today is we will be building an AI model which will train on a set of images from Kaggle. And then we will try to predict whether a new image which the model has not seen in the testing phase, whether there is brain tumor or not. And at the end of it, at the very bottom part of the notebook, you will see that we can also host whatever we have built in the form of a website using this package called Gradio. So we'll do all of this in the first half of the lecture today. So let's start together. So first, you scroll down and click on this hyperlink. So in data set description 1.1, click on this link, brain MRI images for brain tumor detection. It should open a Kaggle notebook for you. If it's showing a redirect notice, just click this kaggle.com/that particular link. Can you put in the chat if you have reached here, just put yes, so that I know you are also following with me. Okay, Aradhya, you have, okay. Okay, I assume this is very straightforward. Now, yes. So Bhavika, instead of doing that, just go to the, do you want the Google Colab notebook link? This is the link. Sorry. This is the link. And in Google Colab, you scroll down to section 1.1. There is this hyperlink here. So just click that. I mean, I can also share this link, but you can get the hyperlink anyway. And here, if you are logged in, I think you should see a download 16 MB button. Just click that. I think it should anyway appear, and you may have to log into Kaggle using your Google account or any other account. But basically, if you're already logged in, you should be able to download the data set of this file of 16 MB. Just do that. And once you are done with the download, please type yes, please type downloaded in the chat. But I'll just show you meanwhile, if it is taking too long for any of you, I'll just show you in the meanwhile how this downloaded folder looks like. So this is the...
So can you repeat what link and what you have to download?
Yes. So in the Google Colab, you have opened the Colab, right?
Yeah, sir.
Yes. So here you scroll down to section 1.1. And here, do you see this hyperlink called brain MRI images for brain tumor detection?
Yeah.
So click that. Then when you click that, the Kaggle will open. I hope this much is done, right?
Okay.
Okay, so once Kaggle is open, you should see a download button here on the right-hand side top, this black button. Just click that to download. You will have to log in, I think, for you to be able to download, but you can log in after clicking the button. Is that done, Bhavika? And anyone else who has downloaded, just put in the chat you have downloaded, so that I know.
One second, sir. I'm in Kaggle. I'll download.
Yeah. I'll just show the structure of the folder after downloading it, so that all of you can. So this is the folder name will be archive. It will be in a zip file. You'll have to unzip it. Okay, Rahul has done it. Aradhya has done it. You'll have to unzip it. And after you unzip, if you open, you will see these 3 folders. I'll wait here for all of you to finish this. Are we almost here? Have you unzipped the file? Okay. Ashi, do you mean you have unzipped or you have downloaded? Which one do you mean? Okay. So in that...
Sir, after downloading, what do we have to do?
So after downloading, do you see the file? It should be a zip file, archive.zip or something like that. That should be the file name.
Yes.
Okay, you have to unzip it. So in Mac, I don't need any special software for unzipping. I can just double click. If you're using Windows, I wonder if you need any other software, or if it's already directly possible in Windows. I have not used Windows in a long time, so not sure. But let me know.
Use maybe WinZip or 7-zip. Or
yeah,
Windows.
if you have trouble doing that, just let me know, because then I can directly share this file, unzipped file, using Google Drive, if you have trouble unzipping it. So what we have currently done is data set collection from Kaggle, but in reality, in a very big project, we may have to create our own data set. We may have to get data set from multiple sources. So recently we had published a paper on detecting human written text versus large language AI written text. We had written a paper and it got recently published. In that paper, actually, when we used the data set directly found from Kaggle, we saw that it was not good enough. So we had to create our own data set of human generated text versus AI generated text. So we took some textbooks on essay, which was published well before ChatGPT was out. So we used that text as human generated text, and AI generated text we separately generated using ChatGPT. So that we'll have to do, but ultimately this all boils down to the step of data collection. So in all of your individual projects, one of the very first steps you will be doing is, where can I find the data for my project? How can I collect it? Is it in a usable format? So here, if I'm not sure if this data set is good yet, right? I have to open this file folder and see. So let me click this yes. I can see that there are a bunch of files here, and yes, these are indeed brain tumor data set, and looks like in this yes folder, most of these images have some sort of tumor looking thing. So it looks like in general, this is a good data set. Similarly, if I go back and if I open no, if I open no, hopefully it should be images of brain tumor without any issues. So it looks like that's the case. So the data set is fine now. And now next what we have to do is you go to your Google Drive. So open Google Drive. And after opening Google Drive, just upload, click this plus icon, then upload, click on new folder. And you can type, actually, I don't have to create a new folder. I just need to upload. So folder upload. And then upload this archive to folder. Just so on Mac, I just need to click this and click upload. Then it should be uploaded. For most of you, it should be similar. Did you understand what you are supposed to do? Go to Google Drive and upload this unzipped folder, not the zip folder, unzipped folder, just upload that on Google Drive. Just let me know okay. Have you done? Aradhya, do you mean, when you say done, do you mean you have uploaded to the Google Drive? Is that what you mean? Okay, awesome. I'll wait for 1 minute for all of you to finish this. This is actually a very small folder. I think it's only like less than 20 MB, so it should not take you too much time. Okay. Just let me know. Everyone, please put in the chat if you have uploaded the unzipped folder to Google Drive. If you can't finish this step, you will not be able to run the Google Colab notebook from here on. So this is probably the most important step. So it's just, if you have any trouble, just let me know. Unmute yourself and let me know. Okay, Ashi has done awesome. Just notice the file folder name. Okay, I have put some random, I think it's just archive2. I would probably, it was called as archive2. Okay, for me, it's archive2. For many of you, it might be just archive. Okay, most of you seem to have done it. Now let's get back to Google Colab. So this much, once this much is done, come back to Google Colab. So what we have done so far is we identified the best place from which we can find the data set, Kaggle. We downloaded it onto our local computer. We unzipped it so that it's not in a compressed file format. Then we uploaded it on Google Drive. So the reason why we uploaded it on Google Drive is because Google Colab and Google Drive being the product of the same company, you can directly connect Google Colab with Google Drive. So if the data set is on Google Drive, it's very easy for us for many things. So that's the reason why we uploaded things to Google Drive. And here there is a particular encoding that we will use. This is 0 or 1. So no means 0, no as in no tumor. If the image has no tumor, the encoding that we are using, which is just a numerical representation for no, is 0. A numerical representation for yes is 1, right? And there are various types of brain tumors. I don't want to go into the biological details of that, but essentially, as you saw in the image, you will see in most cases the tumor is very pronounced, but in some cases it's not pronounced, so you won't be able to predict. That's the whole point of using AI. Like even for experts, it might be sometimes difficult to predict. Now come to the bottom part of this. Come to this setting up the environment, import statements. Just come to that. All you need to do is like click to run, but there are a few things that I want you to note here. So what we are doing here is importing certain packages that other people have written. So packages are simply things that will make your life easy. So here there are already existing convolutional neural network models that other people have written, or at least the parts of those models which you can directly adapt. And there are other packages which will allow you to perform metrics calculations, or packages that will allow you to make plots, etc. So this is just like packages in C++ or packages in any other language. You can think of them as functions, predefined, almost like functions. All we are doing here is we are importing some of those useful packages. So import OS, you will see almost in many codes. Here is where ChatGPT will actually be helpful, right? So all you need to do is copy this and go to ChatGPT, paste it here, and ask ChatGPT, explain line by line what each of this means. This is one of the best ways in which you can try to understand any complex looking code. It makes it very easy. Even we use it even today for most of the complex codes that we come across. It's impossible otherwise to learn coding. How much time will you take? So, but here it explains to you in a very nice way. Basically, import OS is a way in which Python can interact with your OS, right? So sometimes this is needed if you want to deal with saving some things into your computer and many other things. So for example, sometimes when we run ChatGPT using Google Colab, we do something called as API calls, making API calls. It's nothing but using GPT without going to the ChatGPT interface. Like this is ChatGPT interface, what you see right currently. But you can also run ChatGPT without going to this interface like a web developer. So for that, there is something called API key. And this API key is like a secret key which we cannot display to anyone else. So usually those are stored in this environment variable. And this import OS package is very important for dealing with these environment variables. Then Keras is basically a library which you will almost always use. And TensorFlow is also a very important package. I think it was created by Facebook, if I'm not wrong. I think PyTorch was Facebook, and who created. Okay, this was Google, and I guess PyTorch was Facebook. So TensorFlow and PyTorch is something that you will almost always come across in your rest of your ML AI journey throughout your life. So this is a similar package. Here we are importing something else called sequential. Sequential is nothing but it helps you add different layers to your convolutional neural network, which you will see in a moment what exactly it looks like. You will be able to add two layers in the hidden layer, then add output layer of this much dimension. So you can do all of that using sequential and a few more other packages. So I don't want to go into the details of this because that is not the purpose of this lecture, because that will take an entire another lecture. But just understand that in this line, in these lines of code, we are taking some packages which are useful for the rest of our code. So just run this part. It may show this was not written by Google or something, but it's okay. Just run this. I hope everyone has reached this stage. If you have, then go to the third section. This is data import. This is the section where we connect the Google Colab with Google Drive. We have to do that because just uploading data to Google Drive is not enough. So I will show you visually where you will be able to see this data set. So once we upload it in Google Drive, do you see this folder icon on this left side? This is this folder icon. Just click that. And here you will see a bunch of folders. But right now, you don't see the Google Drive folder. That's because you have not connected Google Drive yet. So what you do is you run this line of code from google.colab, import drive, and then you are mounting the drive. then this pop-up will show up. Click connect to Google Drive, and then another pop-up will show up, and it's asking you permission basically to connect the Google Drive. Just give the permission. This is completely safe. And you will have to log into your Google account if you haven't saved the password already. But basically, this step will connect your Google Drive with Google Colab. I will wait here because I want all of you to finish this step before I will proceed. So please please type done in the chat once you have done this. But after this mounting is done, see it's showing now mounted at content/drive. If you click this refresh button over here, you should see that the drive has been mounted. So what this means is I have successfully connected my Google Drive with the Google Colab. And here, if I click, I should be able to see all the folders that I have in my Google Drive. So you can see that here. So these are all the folders, and archive2 was the name of the folder. Yeah, Bhavika, please, you can unmute and ask.
So after I run that drive, whatever that is,
Yeah.
what do I have to do?
Did you get a pop-up asking permission for?
Yeah, run anyway. Yeah.
Right. And does it show? Oh, that was for, yeah. Okay, run anyway. So you have run this part, this part of code?
No, I ran the third A part.
Okay, I think you have to run this first or second, does not matter, but ensure that every block of code is run. So first, this is the very first block of code. So run this first. All you need to do is like click this run button. It should not take you more than 2 seconds. After that, run the third block of code. Click this and run. That will show you another pop-up, and that pop-up should say asking you permission to connect Google Drive with Google Colab. Then once that is done, you should see this mounted at /content/drive. Once all of you have reached this stage, please let me know. This should not take you more than 30 seconds. Okay, excellent. So I hope all of you now see this. Okay, all of you. Okay, Bhavika, you also hopefully you have reached this stage. Let me know if you face any difficulty. But if you click this folder icon, that's where you will see this drive, my drive, and then in that you will see all the folders. So in that I can see the folder that I had uploaded. It was called archive2. It's here. This is the folder. So I found it. So similarly, you also find the corresponding folder of archive, whatever. It is archive2 for me because I had downloaded archive twice. So automatically my Mac renamed it as archive2. Maybe it's for you, it's archive or archive1, whatever. So just find this folder. Yeah, another question, Bhavika, do you have?
Yeah, I'm not getting an option to connect it to my drive.
What do you see right now?
It just finished the two, I just see two green tick marks beside those play buttons.
Oh, and do you see this mounted at content/content/drive?
1 second, I'll just check.
Yeah.
No, I didn't.
Can you click the run button once again? Because by default, all the code has tick button. It's because Raj had run it before. So we are not seeing our tick. We are seeing his tick. So
Okay. Yeah, I see that mounted it. Okay. I have to run 3A, right? Acha, yeah, I got it.
Yes, this one. Yeah, data import. So here what we are doing is we want to somehow get the data from Google Drive into Google Colab. That's our goal, right? We uploaded it, and how do we do that? First, we have to connect, because Google Drive is a private thing. Nobody should be ideally able to access it other than us. But here, although Colab is a Google's product, we are still allowing Colab to access Google Drive, and for that we have to give certain permissions. So that's essentially what we are doing here in this mounting step. So once you do this, you should see the Google Colab. When you click this folder icon, you should see the Google Colab, drive here, drive folder, my drive. And in that, you will see some other folders which you have created. In that, you should see this archive. I hope archive is the name of your folder which you downloaded from Kaggle and uploaded to Google Drive. You should be able to find it. Please let me know if you cannot find it. Okay, so assuming you have been successfully able to locate the folder, now let's go to 3B. In 3B, this is something we are converting the label into something called as one-hot encoding. One-hot encoding is nothing but if you have 10 different items, one-hot encoding for the first item will be 1, 0, 0, like that, 9 zeros. One hot encoding for the second item will be 0, 1, followed by 8 zeros. So similarly, if you have two items, the one hot encoding for the first item will be 1, 0. For the second item will be 0, 1. So here, all we are doing in this block of code is converting our 0 and 1. What was the 0? 0 means no tumor. 1 means yes, tumor is there. So we convert that into this one hot encoding format. So just run this. It's a very simple, it should not take you any time. You will see this one hot encoder has been defined. You don't have to understand every nuts and bolts of this. I also assume certain things here. I also don't know the entire thing behind, oh, what does this encoder.fit function do internally? I have no idea, and nor do I have time or interest to figure it out, because if I don't like to dedicate my life to learning entire functions that other people have written to make my life easy, right? So it should not be our job, but our job is to focus on what are we trying to do here. Ultimately, we want to build a good convolutional neural network model that can predict whether there is tumor or not on our data set. If the data set is cats versus dogs classification, you should be able to do that. So that is my goal. So that's what I'm trying to focus. But I will try to the best of my abilities and to the best of all the practical needs that I have, I'll try to understand the functions, right? So that's what I'm doing here. So I know that some of you who are really into these things might be wondering what exactly is happening inside the function. Either don't worry about it or try to read it in the documentation of the function. That's all, right? Otherwise, you can understand at a broader level what's happening in this code. Now comes the interesting part.
So,
yeah, Avika.
Do I have to download the archive.zip over here or something? Or do I just have to locate it and keep it?
You just need to locate it.
Okay.
So that will come in this current step. So now what you have to do is in this block, this block does not have a name, but basically in the 3B data processing, you will see the second block called this cell updates results list with result list for images with tumor. In this block, you should see a folder path like this. Do you see this folder path /content /drive /my drive, etc.? So what you have to do here is let us okay, I don't think we have to do. Let me run this and I'll tell you whether we have to change the path or not. Okay, I guess we have to change the path. Just a second, let me just change the path and I'll let you know whether we have to do something or not. Yeah, Pratibha, you have a question? Pratibha, you have raised your hand. Please feel free to unmute. Yeah. If you are speaking, I cannot hear you for some reason. Oh, yes. Show again how to upload the drive file. Yeah, to upload the drive file, have you downloaded in from the Kaggle? Have you downloaded? Just put done in the okay. So if you have done that, just go to Google Drive. Here there you will see this new. So here just click folder upload. That's how you upload. But now I assume you're asking how to connect the Google Drive into Google Colab, right? Yeah. So for that, all you need to do is run this piece of code. If you run this piece of code, it will ask you permission. Okay, that also is done. Yeah, these two blocks. Just wait a second. I was just running to make sure that before telling you what to do, I'm also doing the right thing. So here, originally you will see two paths like this. Let me plus Control Z. Originally, you should be seeing path like this /content /drive. So this is not the actual path. The actual path is this. So what you have to do is locate the archive folder. Click on these three dots in the yes. So find this open. So click this arrow, right arrow to open that. Here you see the yes folder. Click on the three dots. Click copy path. So this will copy the actual path, and you should replace this entire path with the copied path, because this is the path that I have. So please do this. And for this is the images corresponding to without tumor, right? That's what we're doing. Cell updates results list for images without tumor. Oh, I have another. Actually, you know what? Maybe this is the folder that we should be using. 1 second. Okay, perhaps we will use this folder. Okay. So guys, just one more thing. Let's do this. Click on archive. Then you will see 3 folders: brain tumor dataset, no, and yes. Then click on the brain tumor dataset once again to open it. In that, you will see another no and yes. So we have to get the path to that no and yes, not the no and yes in the outside folder. So click on this yes, three dots on the yes, copy path, and paste it here. You can also manually type, but then you will most likely make a mistake. That's why manual typing is not encouraged. Then copy the path to the no and paste it here. So ideally, your path should read something like, my drive something / my drive / archive / brain tumor dataset / yes. The other one should be / my drive / archive / brain tumor dataset / no. Can all of you put yes if you have done until this stage? Oh, Bhavika, you can't see archive.zip. So it won't be archive.zip. It will be just archive.
No, I can see archive.zip. I can't see the 3 brain tumor
That's
dataset
because,
and yes and no under.
oh, you did not unzip it before uploading. So you'll have to
We
unzip
have to
it.
put the zip one now.
No. Unzipped one we have to upload.
Okay.
Yeah. Pratibha also cannot see the files on left side. So to see the files on left side, you'll have to click this this folder icon. Then you will see 2 folders like this. One is called drive, another is called sample data. You will see this only if you have connected Google Colab with Google Drive. So if you have not run this piece of code, which was from 3A data import, if you have not run this, you will not see this. So run this this entire block by just clicking this thing, and you should see this mounted at content/content/drive. If yes, you should see this drive. If you see this drive, okay, awesome. If you see this, click this to open it, then you will see my drive, then click again to open it. Then after that, just scroll down to locate your archive, not archive.zip, just archive. So that is this. Then again, click the brain tumor dataset. Then it will again open a no and yes folder. That is the one that you have to pick. And that is the path that you have to add here, because only then you will get the dataset. Please let me know if you have all done this. And then run to these 2 blocks of code. And this should ideally, collect all the information about brain tumor dataset with yes brain tumor and no brain tumor. Can everyone put yes, or if you are currently doing it, can you just type doing so that I know you are trying and not getting? Okay, done. Okay, yes. Has anyone not got this for any reason? Okay, Bhavika is doing. Please unmute, feel free to unmute and let me know if there is any difficulty in figuring this out. But assuming that Bhavika and Sarthak, both of you will catch up, I'll just move on to the next line of code. But please let me know if you want me to pause for another 30 seconds. Okay, assuming you guys are figuring it out, then let's go to this line of code: data equal to np.array of data and data.shape. So if you run this, you should get a set of number called 139, 128, 128, 3. I will not explain what is this. Can any one of you unmute yourself and explain what is this? Does anyone understand what this means? Why exactly it's showing 139, 128? What are these 4 numbers, random numbers?
Maybe they are the rows and columns and how much data is there in each of them.
So when you say data, here the data is images, right, Zishan?
Yes, sir.
Right. So can you explain what you mean by rows and columns?
Is this testing and training data?
Rows are the horizontal one, columns are the vertical one.
So actually here, before even come to all of that, just have a look at this folder, archive folder, right? So let me go back to archive folder. Let me open my brain tumor. Yes or no? These are the images, right? And if I right click, get info, it should show that the size of this image is actually, okay, it's a little bit big, but basically if I select all, there are 155 items here. Do you see this 155? And then in this no folder, there are 98 items. So what we are doing here is we are, let's look at this line by line. We are creating initially an empty array called data. In that, we are adding images. And what do you know why this is called? This is 128, 128. Essentially, we are converting all these images into one single size. Oops. So these images, if you look at the images from the archive, they are all different sizes. Just check this. In get info, this one says it's 400 by 369, the dimension. Whereas this one is 279 by 354. So each of these images are consisting of different number of pixels. And that is generally not good, because in machine learning, whenever we build these convolutional neural network, we have to have images of same dimension. So what we are doing here is, do you see this image resize function? What we are doing is we are converting all the images of 400 by 300, it could be 579 by 268, whatever it is, we are resizing it into 128 by 128. So the pixels will be just 128 by 128 in dimension. This comma 3 is there because there are, it's like a color image, RGB. So there are 3 channels. Although it looks like black and white, in reality, it's like it has all the 3 channels. So that's why you have 128, 128, 3. And what we are doing is, to this variable called data, we are appending these images as an array. np.array means numpy.array. Let's not go into the details of this. You will have ample opportunity to go into details of what is numpy and everything when you run the project. But just understand that we are adding the images into this data array, which was an empty array before. So whatever images that are there in this yes folder and no folder, it's getting appended to this data. And when we run this, essentially 139 is the total number of images that have been appended. Then 128, 128, it's nothing but the image resolution. 3 means it's an RGB image. It's not a black and white image. That's what this means. So please, I'm hoping that you have all pasted this file path. Just run this block, run the 17th block, and also run the 18th block. At the end of it, you should see this 139, 128. Yeah, Rahul, feel free to unmute.
Yes, sir. For the last one, I'm
Yeah.
getting 140, 128, 120 like that. Is it fine?
I hope it is fine. I also was wondering, like, why is this showing 139 if I have... So here you see, I actually have more than that. I have 155 items here, and I have 98 items in the other folder. So I was expecting to have 253 instead of 139. So I could not figure out why this is happening. Yeah, Rahul, you have another question?
No, sir.
Oh, okay. But if any of you can see why it's getting 139 for me and it's maybe because I probably somehow did not upload that many. I don't know. Maybe somehow everything did not get uploaded or something. I'm not sure. But I was not expecting 139 to be here. I was expecting 253 or something to be here. But it's okay. Does not matter. We can move on. Then let's just run this. So see, print total number of images that we have. It's printing 139. So when you run this line of code, you should see whatever number you have here, that number should get displayed here. Can you run this this block? I think it's a 20-second block. Can you run this 20-second block and confirm that whatever number is here, you're getting the same number here? Please confirm and then I'll move ahead. Okay, Siddhant, excellent. Now, what I'll do is, I will just run this part. Result equal to np.array result equal to reshape. Okay, Rahul, you also got it. So just make sure that you are running all lines of code here. So whenever you see reshape, just understand that we are just converting converting an array into another shape. So let's say a 4x3 array has 12 elements. When you say you are reshaping a 4x3 array into 12x1, the number of elements will remain the same. But here, I don't know who typed the 139, whether this was already here or whether it was a coincidence. Maybe Raj only typed this, but it essentially just understand that we are just reshaping this result array. So result is, whenever you want to see something, just type it. And then it will print it. So print result, see it's printing. So can anyone tell what is this result? What is this being printed?
So it is stating yes or no, right? How we encoded it.
Exactly. So you know what? If you have 140 here, is everyone having 139 here? Is anyone else having 140 or some other number? Can you confirm if you have any other number? 139 only, okay. If yes, that is fine. If anyone has 140, they should use that number here, okay? Whatever number you have here, you should use that here. So basically every
It is not running.
Oh, for you it's not running?
No, NPRA is not running because I think what did you do with the brain tumor data set? Yes, no, I didn't understand there because it wasn't downloaded.
Okay, so now do you see this folder?
Yeah, I see that now.
Okay, so open the brain tumor dataset, then you should see another yes or yes no folder. You see that, right?
Yeah.
And what you have to do is in the yes folder, click the 3 dots, then click copy path.
Okay.
And then you have to paste it in this block, which says this cell updates result list with images with tumor. There, replace this path with the copied path for the yes.
Okay.
Then here, do the same thing for the no. Click on the no folder 3 dot, copy path and paste it here. Then run all the blocks until the np.array. Then you should get the result. Okay. Okay. So here, what we are doing is, if you remember the one hot encoding, it was 0, 1 or 1, 0. So we have for every one of the 139 images, we have a one hot encoding saying whether the image is a tumor image or no tumor image. That's why we have the shape as 139,2 here. Okay. Now that I should not have printed this. Let me just run this. So whenever you don't know what something is, just print it. That's the best way. Then you can see what it is, just like how I did. Now we do something called as train test splitting. Train test splitting is something that you might be already familiar with. We had discussed it, I think, in the previous lecture also. It's nothing but from the data set that we have, we reserve 20% of it or 30% of it for testing and use the remaining 70% or 80% for training. It's like studying for exams. Like instead of mugging up the entire textbook, you learn some things, you practice certain questions, and some questions are reserved just for the exams. You may not have gotten exposure to those questions before, while studying, but you will get exposed to those questions only during exams. Just like that, here we define the train test split. So here we are using an 80-20 ratio. How do I know that? Because in this train test split function, here you see that test size is 0.2, which means naturally train size is 0.8. So here, the 139 images we are splitting. If you run these 3 blocks, you will see that the number of training images is 80% of 139 and number of testing images is 20% of 139. If anyone has a doubt, just print this. Print 0.2 multiplied by 139. This should be 28 or 28 point something. See, 27.8. So it's rounded to 28. So this is how you get the 28 and 111. So what this means is from the 139 images, we randomly make a split where 111 is reserved for training, 28 is reserved for testing. So those 28 images will not be used to build a neural network. Now let's come to the fourth block, which is building the AI model. Pratibha, you said you were getting some error. What error? Can you explain? Not sure. Are you guys all almost here? We can let me just move ahead and show you the grade until the app hosting. Then we can. Okay, Bhavika, yeah, you can unmute.
Yeah, sir, I'm still not able to run the NP array. It's showing some red
Really?
exclamatory sign.
Okay, so you ran the code block number 19, 20, 21, right? 21 is
Yeah,
the error.
yeah, this NP array is not running.
Can you read what is the error?
I just see an exclamatory sign and 0 seconds, and then it's not running. This okay. Error is cannot reshape array of size 406 into shape 139, 2.
Oh, it's 406 for you.
Yeah.
Okay, interesting. So here, what do you see in this code block 22? What is the number that you're getting? Are you getting 406, 128, 128, 3 or something?
1 second, let me check.
Yeah. Rahul, you also had a doubt, right? You raised your hand.
No, sir, I got it.
Okay. 21 is the error for you. Okay. 21 is which one? This one is 21. What's the error, Pratibha? Is it? You can just copy paste the error here. Then we know what is the error. Okay. Ashi has also. Yeah, Ashi, you can unmute.
Yeah, sir. I got the same thing as Bhavika, but mine says that it can't, the size of 140 can't shape into 139, 2. But
Okay.
above, the number is 139.
Okay. Here it is 139. Here also it's
Yeah.
139, but here it's
Yes.
size of 140 cannot be. Okay.
Correct.
Are you sure you ran all these blocks? Because it will show the tick, because when we gave you the code, we had already run it. So can you ensure that you have run this block 19, 20 before running 21?
I'll redo and try again.
Yes, can you do that? Because probably that's the issue. Okay, name error. Okay, data. So I assume that for many of you, the issue might be because somehow this block, 19th block and 20th block has not been run. I will get back to all of your doubts. Let me just show you ahead, because it's
So which is the 19th and 20th block?
this one. Do you see these numbers? So whenever 19th means this, if you click,
No,
you
I
will.
can't see these numbers. I can only see.
I think if you click, you should see the next one as 20. That's how you know the previous one is 19. You still can't see
I
it.
can see only till 15th, I think.
You can't see anything beyond that, is it?
No. Yeah, I see 18. Yeah, 18 is NP array, right? That is
Oh,
what
is
I
it?
see.
Oh, for some reason for me, 18 is this encoder, 19 is this thing, 20 is this. Maybe it's because 19th and 20th number are also not running. Okay. Ideally, all you need to do is, I hope you have not made duplicates of the code. Maybe I don't know if that has happened, but essentially, all you have to do is, okay, I won't talk in terms of number, but this block, the cell where you updated the path for yes,
Yeah.
get the path for no. Those two you should be able to run. Is that happening?
I'm getting 128, 128, and 3 for
Okay,
both of it. I
what's
ran it.
so it's 139 comma, is it like that?
Yeah, 128, 128, 3
Like
for
this, right?
image shape is equals. No, like that I'm not getting. Yeah. Oh no, that green color place. No, like this I'm not
That is the
getting.
code. That's not the output. That's the already written code. And this code will not give you any output. If you run this one, data equal to np.array of data and data.shape. If you run that, ideally you should get 139, 128, 128.
I'm not getting that only what you are showing.
Okay,
It's not showing that.
let's do this. No, let's get back to this, because I can show the whole
Okay.
thing first, and then maybe we can go through the error one by one. That may be a bit faster. And
Sure.
then Dr. Rajat also has to cover a few things. So maybe that will be a better approach. But don't worry, these are all simple errors. We can very, very easily fix these things. One more thing. Okay. Anyway, while doing this, just copy paste your error in ChatGPT and see what ChatGPT is saying. This is also something that you have to master. So Pratibha, you are getting an error, right? Then copy that entire error, paste in GPT. Also copy the entire code. So copying the entire code can be done like this. You can, oh, sorry. You can click here, edit, select all cells, and then you can just do Control C, and then you can do Control V in ChatGPT and ask to help you with the error. But basically now we are building the AI model, which is the neural network. And this neural network is something special. It's okay. Ashi, for you, it's working. Awesome. So for you, this neural network is a special one called convolutional neural network. The convolution is a very specific operation. I will do one thing after the lecture. I will show you, share a 2-minute YouTube video explaining the convolution operation. It's very simple. Basically, I can just show you what convolution operation does. There are these beautiful GIF files. So convolution operation, what it does is it creates a smaller version of a matrix. So if the matrix has 8 by 8, see here, a convolution operation is converting this 9 by 9 into a 3 by 3. So it can be in different formats. The convolution operation can be for detecting edges in an image. Sometimes the convolution operation can be for detecting bright regions in an image. Sometimes it can be for detecting horizontal lines. Sometimes it can be for detecting vertical lines. So there are convolution operations for many, many different purposes. And because images consist of lines, circles, bright regions, dark regions, everything, many different types of convolution operation is performed in a neural network that is specifically designed for detecting images. So most of these neural networks are very specialized at doing image related tasks. If you give an input as an image, it will give you a number as an output. So here the image will be the brain tumor image, that the number output that we are expecting is either 0, 1 or 1, 0. 0, 1 means there is tumor. 0, 1 means there is no tumor. 1, 0 means there is tumor, right? So here in this block of code, we are defining the neural network by sequentially adding different layers. Now here I will stop and I will ask you a question. What can, without looking at the code, can anyone tell me what should be the dimension of the input layer? How many elements should be there in the input layer? Like how many numbers, how many values of, how many numerical values should the input layer be able to handle? Just remember, in the input layer, we are providing an image as the input. So a brain tumor image as the input. Each brain tumor image we have reshaped into 128 by 128 by 3 because there is RGB, red, green, blue. So can anyone tell me how many numbers should this input layer be able to handle? Zishan, what do you think?
What,
Do you
128 times 3?
Correct. It should be able to handle 128 times 128 times 3 because that many numbers, that many pixel values are present in these images. So that's why here you see this input shape in the input layer. You see the input shape as 128, 128, 3. Sometimes we will reshape it into 128 times 128 times 3, 1. So that the same number of things are there, but we will elongate it into one single long array instead of putting it as a stack of, here it's like a stack of 128 by 128 stack 3 times. But we can also do it like a single elongated array. Maybe I can show you. Just search for there are some amazing GIF files which explains this. So here you see, here is a 32 by 32 pixel of a handwritten digit 2. And here in the input layer, this is 784. The 784 you are getting because it's 32 multiplied by 32. So this image is 32 by 32, but they are converting it into a long 784 by 1. That's what you see in this GIF. Now I have one more question, guys. Now forget about all the other in-between layers for a moment. The output layer size should be what? What should be the output You can tell anything that sounds logical to you. Just tell what do you think should be the output. Output should be, it can be anything that depends on our, like what we prefer. Output should be a number. What is this neural network supposed to tell you? It is supposed to tell you whether the input image is yes tumor or no tumor, right? That should be the output. And what is the output? What is the number corresponding to yes? Number corresponding to yes was 1, but we converted it into a 1 hot encoding, and 1 hot encoding corresponding to 1 was 1, 0. If you remember from up here. So here we had 0,1 for 1 and 1,0 for 0. Yeah, I think I flipped it when I said it. But label for 0 is 1,0 and label for 1 is 0,1. So the output can be either in this just one number format, or it could be in the 1 hot encoded format. Either is fine. So maybe the output might be an array of size 1, 2, or it can be just a number, just 1, 1, just a number, right? 1 by 1. Or yeah, Rahul, you have a question?
Sir, here the label can be a tumor or normal also, right? Instead of 0, 1.
Usually for labels, we need numbers. Do you know why? Because the neural network in its training, it's training like a baby. So you will show a baby a cat. Then you'll show another cat image to the baby and ask baby, what is this? Then baby might say dog. Then you will tell the baby, no, you are wrong. This is not a dog. This is a cat. So you are correcting the baby, right? Now imagine the computer is your baby. You cannot teach the computer cat, dog, everything. It can only understand numbers. So we have to represent any words or anything else in the form of numbers. So what essentially we are doing here is we will give a random image of tumor or no tumor into the neural network. Initially, it will randomly predict 0 or 1. If it predicts 0, but in reality, if it is 1, we will tell the neural network, no, you have made a wrong prediction. Now relearn. Then it will relearn and try to make a different prediction. Then at some point, it may make a right prediction. Then we will feed another image. Then again, this thing repeats. So that in the training process, basically neural network is forced to go through all the different images in the training data set. It will try to make predictions. And initially, all the predictions will be probably wrong. Not all the predictions, at least half of the predictions will be wrong. And then later, maybe 99% of the predictions will be correct. So to tell the neural network, no, you are wrong, or no, you are right, we have to tell the neural network that in every single step, which is all done in the internal coding. You don't have to do that manually. But this is communicated to neural network by saying, okay, you have predicted a 0 instead of 1. So you are off by 1, like you are off by 1 minus 0, that much degree, right? So the output has to be a number. I hope you understand, right, Rahul?
Yes, sir, got it.
Okay, awesome, excellent. So now I just ran this block of code. I also ran this y-train.shape because training images, we had 111 images, 80% of 139, and 2 was the label. Label was 0, 1 or 1, 0. And here is the part where the training happens. There are a few parameters here. I know that I'm going a little bit fast here. It's also in the interest of time, but I will make sure that all of you understand this. I'll share an interesting link to you in the WhatsApp group, which you can go through. But this is very simple. Don't get intimidated by the code. Here, all we are doing is we are trying to fit the model. The fitting the model is like teaching the kid. Here is where we are teaching the kid. So here we are trying to make the neural network learn through these images 30 times. That is what this epoch 1 out of 30 means. It's like reading a textbook. So imagine you are preparing for an exam and you read the textbook once, then you read the textbook twice. If you read once and if you try answering, let's say 100 questions, you may get a lot of them wrong. So this loss is nothing but it's an index of how bad the neural network is. So in the first epoch, it is this bad. Validation loss is like 72. The training loss is 15. In the second epoch, it's even worse. According to loss, right? It's 22. Then you will see that as the epoch progresses, it's 3 out of 30. Then it will come to 29 out of 30. Then loss will slowly decrease. Initially, loss will be a bit high number. Then slowly you will see that it's decreasing. And this loss is a very, very important parameter all of you should note, because in your projects, your singular goal should be to minimize this loss. And there are a few things you can do to minimize this loss. So here I have selected epochs 30. What if I had selected epochs as 2 instead of 30? Then my loss would have been 22. But because I selected 30, now my loss has decreased to 3, right? Here I have put batch size 40. Maybe if my batch size was 10, maybe the loss would not have been 3. Maybe it would have been 7. And then my train test split was 80-20. If my train test split was 70-30, my loss instead of 3, it would have been 2. Who knows, right? I have to do experiments to know this. So this process of minimizing the loss by changing certain parameters in your model, like epochs or batch size or train test split, and there are a few other parameters. It's called hyperparameter tuning. And it's also very important in every single one of your projects. The moment you come to Google Colab and try to run a model and try to run this function called model.fit, your singular mission is to minimize the loss. And to minimize the loss, what you will have to do is identify the right parameters. You can initially start with some parameters that maybe ChatGPT might tell you, but it may not work for you. It depends on the problem statement. So we have found these parameters through certain experiments. We have run certain experiments ourselves and realized that, okay, these parameters look good, but I'm not claiming that these are the best set of parameters. Maybe you will be able to find even better parameters. You might be able to see that if batch size is 45, it's even better. But we found this to be good enough. So here, do you see that loss is gradually decreasing as epoch is increasing? Essentially, this is like you are reading the textbook again and again and again and again. And then whenever a question you are encountering, you will most likely not make a mistake. And usually, the degree by which we have to reduce the loss, I usually prefer loss to be 10 raised to minus 2 or less, like 0.01 or lesser. It's not always possible in all problem statements. If it's possible, I will try for that. Otherwise, I'll be happy with, let's say if the loss is 0.1 or something like that. So here you can see that the loss is already less. You might be wondering, how did I come up with this number? And this is related to the question Rahul asked. So Rahul, you asked, right, the output, whether it can be English words like tumor or no tumor. The loss is basically, if tumor is represented as 0, no tumor is represented as 1, then there is a function using which we can calculate the loss. It's like log. You can calculate this. It's using something called as categorical cross entropy loss. So for example, so there is this function. This is a simple function using which this loss is calculated. And the number that is coming out as a result of calculation done by this function is the loss that you will get. And this function can vary in its shape and form. There are many different types of loss calculating functions, but this function is called categorical cross entropy loss. I don't want to go into the details of the theory of this because then the practical side of that will be lacking. But all you need to understand here is that we are telling the neural network by calculating this loss that, hey, you are doing a good job because your loss is very less. So keep doing what you are doing right now. And let's run the epoch. So the epoch is progressing. But I'll just show you after that what is supposed to happen. While this epoch is running, this may take another 2-3 minutes. After this, we'll be plotting the loss of this model. Now, if we plot the loss, the test loss and validation loss. So validation loss, you can see it's like it's also decreasing, right? So initially validation loss is 72, 18, 4, 35, etc. It's coming down. Test loss is even lesser. So sorry, train loss is even lesser. Can anyone explain the difference between training loss and validation loss? What's the difference between training loss and validation loss? Since you're maybe confused or maybe not clear, training loss is nothing but neural network is exposed to certain images, right? And so those images using which neural network is trained, in the training process itself, neural network may make a lot of mistakes. So training loss is nothing but when you are learning using textbook and when someone is asking from the textbook itself, you may still make a mistake. And this training loss is the loss of the neural network, meaning the degree of mistakes the neural network is making on the training data. Validation losses, in this particular context, validation loss is nothing but the degree of mistakes it's making on the test data. And almost always, test loss or validation loss will be greater than training loss, simply because training loss, it has already seen the data. The neural network is seeing it. It's seeing, so here in the 10th epoch, neural network is seeing the same training data for the 10th time. But validation data is just for testing, or the test data is just for testing. It's not taken into account for building or training the neural network. So always, almost always, the validation loss or test loss. Yeah, was anyone asking a question? Almost always this loss will be greater. So now all the epochs are almost finishing. And let me run this code. Hopefully it should not, yeah. So this was the 30th epoch, and you see the loss here now. My goal was 10 raised to -2. It has reached 10 raised to -5. It's very, very good. But then sometimes it increases also because of a phenomenon called overfitting. So do you see what's happening here? The yellow is basically the validation. Green is actually green. Green was the test loss, and okay, in this context, green was test loss and this was validation loss. But you see validation loss is almost always greater than the other test loss or even training loss. So this green plot is that, yellow plot is the validation. And now let's test the actual model, okay? So I'm running this. Don't worry about getting this code to work right now. There is no rush. Okay, here the path is wrong. Here I should pick a path that so I'll pick from a different folder. So this is a yes image. This is a image with tumor, and these images the neural network hopefully has not seen, and cannot reshape. Oh, okay. Perhaps. I know why this is happening, because we have not, the image resizing we have not done. So what we can do is, actually, let me show you till the end, and then I can come back and fix this error. But you can see that okay, so for many images, it's working. So here it's predicting with 100% confidence that yes, this is a tumor image and it's correct. Now let's do the Gradio app hosting. So here you can put I'll explain to you later in the after Rajat section, or if we have time, I'll create another separate small video explaining this part in the WhatsApp group. But basically here I can put any name, Sridhar's tumor classification app, and then run this. This is for the Gradio app. And then here I want 4 numerical examples, then run this. Then let me run this part. Example path 1. So I'm just putting some paths for sample images. Okay, so I have provided 4 paths. Probably the example path 1 won't work very well. Let's see. Then run this. Run this. I just want to show you the hosted app. That's all I want. So this is how you fix the error. If you don't know, so currently I am encountering an error that no, there is no module named Gradio. Then all I need to figure out is how to get Gradio into my app. So I will have to install Gradio here. All of this you can figure out yourself with the help of ChatGPT. Yeah, Bhavika, you can ask your question.
So can't you just use Gemini that's there? If you see there, you
Actually,
can
yeah,
see explain error.
yeah, over here, right? Like
Yeah, there's this thing that comes explain error. So it opens a
actually,
Gemini code.
that's
Yeah.
actually even better than going to ChatGPT each time. It's just that I got so used to GPT that I don't even remember that Gemini was here. But yeah, great suggestion.
Yeah.
I agree. That's better. And now I can import Gradio. So hopefully it should not take too much time to get imported. It's a few second job. And then theme for Gradio interface. All of this is not really important. What is important is ultimately hosting it so that you can see it and share it with others. Okay, so now it has generated a public link, and this is the Gradio app. Hopefully it should have 4 images and it should be able to. Okay, so this is the Gradio app. This is a public link, by the way. If I share this in the chat, just go to this link and check if this link is working for all of you. So I can click an image from here in the example and submit, and it will say it's not a tumor. And if this is a with tumor, I click this, submit. It will say it is a tumor. Click this, submit. It's a tumor. See, there is something that looks like tumor here. So this is the final Gradio app. The only reason why I was going a little bit fast in the second half of the Colab notebook, much faster than the first half, is because Rajat also has to cover a few things. But the idea here is Google Colab is going to be part of your workflow in the next few weeks. So just get accustomed to that. Just get accustomed to, as Bhavika was saying, Gemini or GPT, anything that is convenient for you. And your end goal at the end of this project should be either you should have a Gradio app or some other way you can post it and show to your parents and friends, and then also write a research paper based on the project. This brain tumor project is a very popular one, but there are many unpopular ones that you can work on, that some data sets that many people have actually not explored. So in your particular field that you have you are planning to work on, you can pick that. Now, Rajat, you can take it forward.
Yeah, sure. Thanks, Sridhar, for the detailed explanation. It was very good. I'll just share my screen. Minute. Yeah, so I just want to give you guys a vision of what we are trying to do here. So the main objective of this training is that, let's say, we have our presentations with respect to the projects in November. And I'll just briefly describe the workflow that that we are going to follow. So basically, let's say we pick a problem. So the first step is to pick a project. And so this project will also give you a list of projects, and you are also free to choose your own project. And then this project has to be somewhat impactful, which means that brain tumor, you can see it's very impactful, right? So the project that we'll choose has to have some impact in some sector, let's say healthcare, agriculture, finance, sustainability, economics, etc. There are a lot of fields we can pick from. Then the second step is to data acquisition, which means where is the data going to come from? And what we recommend is that we stick to Kaggle for this year, because this is the first time all of you are going to be building your AI model. So we can get all the data sets from Kaggle. There are some excellent Kaggle notebooks in which the data is already uploaded, and we can work with the data which people have uploaded. For example, in this brain tumor data set, all of you downloaded the data from the Kaggle, and then we built a model out of it. So after you pick a project and you select the data, the third step is, as you saw here, was data processing. And what does processing mean? Here we just resize the data to 128 by 128. So in this example, it was just resizing. And then once the data is processed, then you split the data into training and testing. So here we had an 80-20 division, which is generally the case. In the fifth step, after acquisition, processing, and split is complete, then we'll actually split our AI model. Now, this is a step in which we don't expect you to have detailed knowledge of, let's say, what is a CNN, etc. You can simply use the code block that we have used in this project, or you can get the code block from ChatGPT as well. What we want you to do is that we want you to fine tune the hyperparameters till the accuracy is maximized, till maximum accuracy. Okay, so the first step is to pick a project, and for this we are going to be dividing you into groups. So tomorrow we are going to have our last lecture, and before that it would be good if we get to know the groups itself. So all of you can just discuss within yourself, because tomorrow we are going to finalize the groups. We'll give maybe 4 projects. For these 4 or 5 projects, there can be 2 or 3 students in one group, and then we can have the presentations as a group. And then, okay, after the data is acquired, process, split, and model, the sixth step is to host the model on Gradio. So why we recommend is because it's not good to show Google Colab notebook while you are presenting. People don't understand code. So it's better to show an application which Sridhar just showed right now. I'm not sure if any of you were able to create an application by following all the things in the notebook. If not, you can just try it out once more after the lecture is over. Sridhar has gone through a lot of details in every single section, so I'm pretty sure you guys will be able to do it. So there is a lot of satisfaction once you see the Gradio app up and running. So we need to get this up and running for majority of the problems that we are tackling. And then once it is hosted, after the presentation is done, we are going to spend some time to convert the results into a paper. So many of you have been attending all the lectures. Some of you, I think, have missed some. Just to summarize what all we have covered so far in the last 2 lectures, we looked at Google Colab mainly because once you acquire the data from Kaggle, once this is done, you have to import that data somewhere, or you have to copy that code in Kaggle and work somewhere, and that somewhere is Google Colab. So mostly what will happen is that you won't get a chance to understand all the technicalities of the coding, which is completely fine. Even in industries, the importance of coding is actually reducing day by day. ChatGPT, Cloud, all of these large language models are able to create excellent code for you. So you can imagine that you have a software developer along with you every day when you are working on these projects. Don't let the fear of coding hamper you. Just be very creative while choosing the projects, or you can choose one of the existing topics itself. think about how you can create an application which is very impactful. And if you would have asked me 1 year back, I would have said, yes, coding might be a barrier, but now it's really not. We are regularly using ChatGPT for a code. I don't understand the technicalities of coding that much, but I'm able to build very impactful AI applications. So I just wanted to actually summarize what all we have done so far so that you get a fair picture. And okay, so yes. So what we started out with is that in the first lecture, we covered the introduction to AI. And now actually many things will make sense once we have reached towards the end. So next we looked at teachable machine. And teachable machine is a no-code interface where, if you remember, there was here there are three parts. So training data. The training data is fed into an AI model. And then you test. And now I hope all of you are able to appreciate what's happening under the hood. Under the hood, what is happening is that there is a convolutional neural network which is being trained, and there are hyperparameters like epochs, learning rate, etc. So whatever you see on teachable machine, today we showed you a Google Colab version of that. So you can consider that we are representing the same thing in two different ways. So it is similar to the phases of water. So water can exist either as ice or it can exist as steam. Similarly, if you look at any AI, it can either exist as a no-code platform like this where the entire code is abstracted, or you open up everything and show people about the entire code. So we wanted you to get a perspective on both the things. So that was the second part, which was covered in teachable machine. This was in our first lecture. Then lecture number 2 and lecture number 3 were focused on types of AI. And if any one of you remember it, we covered three types mainly. We covered classification, then we covered regression, and then we covered clustering. Within classification, we looked at brain tumor example. Within clustering, we looked at student performance with respect to the number of hours of sleep they are getting. And in clustering, we looked at an iris flower data set. If some of you have not attended this or forgotten, just go to this link that I'm just sharing in the chat. All of these projects are actually hosted on this link very nicely. So you can click on this and interact with these so that you understand these three types. Every project that you'll be working in will be related to one of these types. For example, today we looked at this one. We looked at brain tumor, which was in the classification category. So classification, in my experience, is one of the most common categories in the types of AI. And regression and clustering are there, but they are not that common. So many of your projects actually might be within this category, the classification category. So we looked at these three examples, and then we looked at AI project cycle. So AI project cycle is divided into 5 steps: data acquisition, data visualization, then modeling, evaluation. Okay, now one example that we looked at where all these things are present very nicely is the Titanic Survivor project. This we looked at in our last lecture. I don't know if all of you attended this. So we looked at the actual Titanic data and tried to predict which people had more chances of survival. And it actually turned out that gender and the class of the person, which class, so which platform is the person, is it in platform 1, 2, or 3, depending on the amount of money they paid, these two had the maximum impact. And all of the projects. Today also you see we did all these steps. And one of the key steps here is data visualization. Many times before you start building the model itself, data can tell you a lot of stories. So many of the stories were revealed to us in the Titanic example. In the iris flower, we identified there were 3 types of flowers even before going to the modeling stage. And then what about the model itself? So this is something we have not focused on in this classes so far. But you have gotten to know some names of models. So one is convolutional neural networks, which we briefly touched upon today. We don't want this to be the focal point of the bootcamp because this makes it very mathematical. On a broader level, you can remember some of these names. Then decision trees. These are 2 of the models which are very popular and they are used in a lot of. So for example, the Titanic project use decision trees, then brain, and then we also looked at this k-means clustering, k-means algorithm, which is used for clustering type of applications. So students who are interested to have a deep dive, these are very interesting topics, and you can look at these either on our YouTube channel. We have a lot of lectures on our YouTube channel, which is named Visuara, but that is not required if you just want an overview of building AI models. Then you don't need to go into the details of all this. Okay, so overall, this is what we have covered, and the final aim, which is very important for all of us, is to solve a very real life problem. So tomorrow we are going to have a lecture, and in tomorrow's lecture, what we are going to do is that we are going to look at one problem from Kaggle itself, how to take it from Kaggle to Google Colab, and how to basically analyze the results. And then we are going to divide you into groups and add you to this Slack channel. I'm not sure if you're familiar with Slack, but it's way better than WhatsApp, because in WhatsApp you are not very focused. You're distracted by a lot of things. Slack, it's like everything is there within one place, and it makes communication very efficient. And we prefer to work in Slack with all the student related projects. So we'll be dividing you into groups. Just be ready before we meet next time, and then I'll also discuss a bunch of projects, and then each team will pick a project. We'll probably give 2 or 3 days for you to decide which project you want to pick. And then in the meanwhile, we'll be guiding groups on Slack. We'll be creating different communication channels for each group, and each group will be guided on Slack separately. So, okay, so this brings me to the end of today's lecture. Just practice this, the brain tumor project more in detail. I'm not sure if all of you were able to reach till the end, but after this session, just make sure you are able to run everything and reach till the end. Are there any questions or any doubts from anyone?
I have a doubt.
Yes. Yeah.
So tomorrow will it be our last session or there will be another session?
Tomorrow it will be our last session. And after that, we would be communicating on Slack for the projects.
Okay, thank you.
Yeah.
Sir,
Any other question? Yes,
could you
Ishan. Yeah.
please upload a recording of this session? Because if anytime we
Sure.
would like to practice something on Google Colab, so we would have the necessary step. We would not be forgetting it.
Sure.
Yeah,
So
I
we'll
was
be doing
about to
that.
say that. Yeah.
Yeah, we have recorded this lecture and we'll be uploading this on WhatsApp, so all of you can take a look.
Okay, sir. Thank you.
Thank you. Bhavika and Rahul. Bhavika, can you ask?
Yeah, we have to form the groups by tomorrow.
Yes, yeah. So we'll be forming the groups by tomorrow. In case you have discussed it internally by tomorrow, it will be great. Otherwise, we can do it ourselves. But if you have internally discussed, we can have maximum 2 or 3 students per group, not more than that. And single students, if some of you work in like just alone in, then it's fine for us. But generally, it will take you more time because you might have exams and some other things also going on. If you are in a team, it makes sense for you because then you can split the tasks among all of you. So let's say one of you takes care of um, the story. How should the story be in the presentation? One of you takes care of the Google Colab part. Then one of you takes care of the fine tuning parameters, etc. So you can divide the tasks among the 2 or 3 of you. Yes, Rahul, you had raised your hand before.
Yes, sir. I have one doubt. Sir,
Yeah.
what generative AI would come under like which category of like classification regression, or is it a separate category itself?
Yeah, that's a good question. So, generative AI is actually a very different category in itself. And how it is different from traditional AI is that, let's say in traditional AI, you try to classify between different classes. In generative AI, instead of classifying, you are completely generating something new from scratch. So it doesn't really fall under any of these buckets. It's a completely new category on its own. All of the recent applications that we are seeing, ChatGPT, Gemini, all of this come under generative AI. And it was not until 2014 or 2015 that the field of generative AI actually picked up. It was because of this development called transformers. I've just mentioned it in the chat. And there is a very nice research paper which is called Attention is All You Need, which actually started all of it. I'm just posting it in the chat. If you get time, just read the abstract of this paper. It is very nicely written.
Okay, sir. Got it.
Zishan, you have a question?
No, sir, I forgot to lower my hand.
Okay. So all of you are clear with the trajectory and the kind of workflow that we are going to follow after today's and tomorrow's lecture. Okay, great. Siddhant says yes. I hope all of you are also clear with that. Okay, Aradhya also has given a thumbs up. All of you have generally followed the lectures. What has your perception been? Has there been any concept or anything which you have found difficult to follow?
No, sir.
So generally, I think many of you have followed. In case you have not followed, it's fine. We'll be in regular touch continuously through Slack after tomorrow's lecture. So it will not feel like there is a disconnection. All of us are very active on Slack, and you will see once you get on the platform, you will see how effective it makes the communication. And I think we'll be able to make steady progress once all of us are there on that platform. Okay, okay, guys. Then let us meet tomorrow. Tomorrow we'll meet at 9:30, just like last week. Last week we met at 9:30 or 10:30. 9:30, right? I think.
Yes.
Yeah, I think we met at 9:30, right? Okay. Okay, guys. Then let's end the session today, and we'll meet tomorrow.
Okay, students. See you tomorrow.
Bye.
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 Thank you, sir.
Thank
Bye,
you.
sir. Thank you.
Bye.
Bye, sir. Thank you.
Thank
Bye,
you.
sir. Thank you.
Thank you. Thank you.